Today we will be going over the test review for our test that we will be taking on September 19th. The first part of our slides is to indicate that there will be two parts to the test. The first part you cannot use a calculator on. You will complete this portion first and then turn it in prior to getting the second part. After you have the second part, you may get out a calculator and use it. For the no calculator portion, you must be able to determine what perfect squares are above and below a number. If I give you the number 37, you should be able to tell me that the perfect square below it is 36 and the perfect square above it is 49. Another example would be if I give you the number 53. The square root of 53 will fall between the perfect square, 49, and the perfect square, 64. You must be able to plot them on a number line. We have been doing this on our last few assignments where we would draw the scale. On the left would be the low perfect square, the one that goes below, and then the one above to the right would be the perfect square above. Remember, we need to find the middle between those two lines and then be able to determine and estimate what the decimal would be. You will have to support your answers in complete sentences. Complete sentences start with a capital and end in a period. They do also have to have reasoning and supports to what you had determined for the answer. So let's do a practice with the calculator. On our calculators that were required for this class, we are able to calculate the different values. So let's do the square root of 17 first. Looking at your TI-30X, you will be able to see that the second button is in the top left corner of the calculator and is typically in a different color than the rest. You will press this button. On the screen of the calculator on the left-hand corner, you will see the letters 2ND for second. Underneath the second button, you go 1, 2, 3, 4, 5 buttons below it. You'll see that there is a button indicating x squared. Right above it, in the different color that matches your second button, you can see that there's a square root symbol. When you touch that or push that button, it will come up on your screen a square root and then an open parentheses. Now we will enter in 17 and then hit enter or equals. Our answer should be 4.123105626. Now with this, we can tell that there is no noticeable pattern in any of those numbers. So we feel that it is not going to be a repeating number. We also notice that it fills the entire screen on the calculator. This is also going to indicate that it is a non-terminating number that does not repeat. In terms of the vocabulary that we had learned over the course of this last unit, this would be an irrational number, a number that cannot be made into a fraction. Moving on to our next example of 5.5 squared, we're going to type in 5, period 5. We're going to actually hit the same button this time as we did for the square root, but this time we're not going to hit second first. We're just going to hit x squared button. You should see that there's a smaller 2 that pops up next to your 5, and then hit enter. This answer will then be 30.25. With doing the square of an answer, it is also possible to do 5.5 times 5.5. Remember, a square is a number just multiplied by itself. Things that you will need to know for this exam. You will need to know what the value of pi is. The value of pi for our exams and most of the items that we're going to be working with is going to equal an equivalent of 3.14. Now, 3.14 is not the exact answer because, as we've learned in class, pi goes on and on and on as a non-terminating number. But for our calculations, we will use 3.14. We will also need to know what is a rational number. We've gone over this. It should be in your notes, but here it is again. A rational number is a number that can be turned into a fraction. So on the flip side, what is an irrational number? An irrational number is a number that cannot be turned into a fraction. Showing work. This will be important on the test. You will need to show work for how you determine the answer. Though you can use your calculator, you will have to show it in steps. So what does this mean? Let's look at an example. Let's look at 17 repeating. 17 repeating is equal to this value. Point 17, 17, 17, 17. And remember, with that repeating symbol, it goes on and on forever. So how do we solve this and turn it into a fraction? To turn this one into a fraction, remember back to last week when we were working with the values of x. So we have to move over the decimal how many places? Maybe once, maybe twice. We want to line it up so that it's able to repeat. So let's try moving it over twice. So we move it over twice. So we're going to multiply it by 100x, or multiply x by 100, and that is going to give us 17.1717. We're then going to subtract a single x. That single x gives us 1717 after a decimal point. And by doing so, we can cancel out numbers that are just junk numbers at this point. We can cancel out the 7s and the 1s behind the decimal points. And what does that leave us? On the left side, we have a remainder of 99x, and on the right side, we have 17. We'll divide both sides by 99, and then our final value of x will equal 17 over 99. One thing we do have to keep in mind is whether or not this answer can be reduced. In this case, 17 over 99 cannot be reduced. So that would be our final answer. And we will put a box or a circle around it. Now this 0.75 is different than the 0.17 repeating that we had in our last example. In our last example, we had this 17 with the bar showing above it, which caused us to believe that it was 17, 17, 17, and it went on forever. This 0.75 does not have a bar notation to indicate that the number is a repeating number. In this case, we have no extra numbers or garbage numbers that need to be removed. We can just place this 0.75 over the value of 100. So we will put 75 over 100. Is that the end of our answer? Hopefully not. Both of these numbers can be reduced by a value. That value is 25. 75 divided by 25 is going to give us 3. And 100 divided by 25 is going to give us 4. For showing work, this would be great. Having just the basics that you had put the 75 over 100, You indicated what you're dividing by. In this case, we divided by 25, and then we got